Today we'll be going over 10.3 cosecant and secant graphs. The first thing to kind of understand before we do anything else is to understand what the inverses of our cosecant and secant trig functions are. So for cosecant, that truly means that we are working with sine, and for secant, we are working with cosine. Understanding those trig functions and how to graph those are extremely important. If you're still having a difficult time with the sine or cosine trig functions and how to graph them, take a look at the 10.1 or the 10.2 videos that go along with it. Here we're going to go over a lot of the different properties that go along with each one of the graphs. Most important things to realize with our cosecant graphs is here we're going to be taking a look at the domain. Now for the domain, what will happen is we will have the integers at multiples of pi be undefined. And the main reason for that is because keep in mind, every single time that we are running into negative 2 pi, negative 1 pi, 0, pi, 2 pi, 3 pi, all the way up from negative infinity to positive infinity, in those cases, you will end up seeing that there are asymptotes at every single one of those different spots. For the range, we are going to be looking at y being greater than or equal to 1, or y being less than or equal to 1. Now, this is extremely important because remember, we are taking a look at the inverses. We are not taking a look at the actual sine or cosine function. In order to have a better understanding of it, highly suggest you keep in mind that this area over here between the two blue lines, this right here would be your sine graph, and these areas up here are your cosecant. And that's what we will be learning how to graph today. Now, there are some spots that are, or some properties that are similar to that of sine, and there are some that are different. What I'm going to go ahead and do is show you which ones are different and which ones are the same. Your domain and your range are both different compared to your sine. Your period remains the same at 2 pi. The symmetry is the same at it being odd, going from the first to the third quadrant. For the x-intercept, it would be different. In this case, you will not have an x-intercept, and the main reason for that is because, remember, everything in between the lines occurs with sine. Your cosecant will remain on the outside, meaning on top of 1 and below 1. So you're never going to have a chance to really touch that x-axis. Same thing is going to occur for the y-intercept, and that will be also another difference. Main reason for that is because you will end up with an asymptote on that y-axis, which means you will never touch that y-intercept. Your vertical asymptotes will be at integers multiple of pi. Now, for our secant graph, keep in mind, remember, this is going to be in reference to cosine. This, once again, is going to be very similar to what we just took a look at with our sine. Now, our secant graph is going to be similar, but slightly different because we are going to have x such that x does not equal multiples of pi over 2 when they are odd. Meaning, if you're looking at a negative 3 pi over 2, negative pi over 2, positive pi over 2, positive 3 pi over 2, or 5 pi over 2, you are always going to have interruptions at those locations because x would not be equal to those areas. Hence the reasons why we have asymptotes at those places. Your range is once again going to be larger than 1 and you are going to have your range less than or equal to 1. So in this case, you can see they will touch the top portion of your cosine function at the very top and at the very bottom of each one of your mountains and valleys. So those upper parts and lower parts of the wave. The symmetry for this will be still odd. Your pi function will still be, or your period will still be 2 pi. X-intercepts will not occur. Your period will still be 2 pi. Your symmetry will be even in the case for cosine. Your x-intercept will be none. Your y-intercept will be at 0, 1. Notice this area right over here will be where that y-intercept occurs. You will have vertical asymptotes at multiples of pi over 2. And that's going to be occurring at every odd multiple. So once again, negative 5 pi over 2, negative 3 pi over 2, negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth from negative infinity to positive infinity. Let's go ahead and take a look at slide 4. The first steps that we're going to take for this graph will be, we are going to go ahead and convert from y is equal to cosecant of 2x to y is equal to sine of 2x. Now we are going to solve that left-hand side of our questions the exact same way. We're still going to calculate our amplitude, period, subintervals, phase shift, midline, and range the exact same way we did before in 10.1 and in 10.2. Our amplitude in this point would be 1. Our period would be 2 pi over 2, or pi. Our subinterval would be pi over 4. Keep in mind, every single time that we have our period, it's going to be 2 pi over b. Our subinterval is our period divided by 4. Our phase shift is negative c over b. In this case, we do not have a c, which means 0 over 2, which is equal to 0. Our midline is equal to d, which in this case will be 0. And our range would go from negative 1 to 1. Keep in mind, you start from the midline. You use the amplitude to add and subtract to find the minimum and maximum numbers. From this point, once you have all of your information, you're going to go ahead and you're going to graph it on the right-hand side. First thing you're going to start off with is your midline. Now that midline, you're going to go ahead and draw that horizontal dotted line to represent that being the midline. Now, with us having a subinterval of pi over 4, that means that we will have pi over 4 at each one of these locations. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Now, we are working with a sine equation. So the first thing you're going to start off with is drawing that sine equation. Now keep in mind, since it's sine, you're going to work from the midpoint. And from there, since it's positive, you're going to be increasing from your midpoint to your maximum. So in this case, we're going to start off at 0, 0. We would go up to the maximum, back down to the midline, drop down to the minimum, and come back up to our midline. You go ahead, draw out your graph. And this will give you a better idea in order for you to be able to also graph the cosecant part of this graph. Now, every time that you have one of your dots hitting that midline, it is going to create a vertical asymptote. So that vertical asymptote will occur at 0. It will occur at 2 pi over 4. And it will occur at 4 pi over 4. One of the easiest ways to be able to graph this out would be to look at it as far as your mountains and your valleys. Each time that your sine equation and that graph creates almost like a mountain, it goes up then back down, what's going to happen is that it's actually pointing towards where that cosecant graph will be. So in this case, your cosecant graph will occur from that same dot, and it's going to go towards both of your asymptotes. You're going to do the same thing for the second asymptote, from the second line to the third line. This is going to create a valley, and notice it is pointing downward, which means your cosecant will open downward. This is exactly what is needed in order for you to be able to graph this equation properly. Let's take a look at slide 5. Once again, we're going to begin with rewriting this equation. Now, in this case, we have a 2 on the outside of our parentheses. So when we rewrite this, we are going to distribute that 2 and convert it from cosecant to sine. So sine of 4 pi x plus 2 pi plus 3. You go ahead, work the left side the exact same way we have been doing. In this case, our amplitude is 1. Period is 2 pi over 4 pi. Keep in mind, pi over pi cancels out. 2 over 4 simplifies to 1/2. Our subinterval is 1/2 divided by 4. That will leave you with 1/8. Our phase shift is going to be C, which is 2 pi, and that will be negative, over B, which is 4 pi. Here you're going to end up with a negative 1/2. Now keep in mind, when we have our phase shift and our subintervals with different denominators, we want to go ahead and make sure that they end up with the same denominator. In this case, this would convert into a negative 4 over 8. Our midline would be 3, and our range would extend from 2 to 4. Once we begin going ahead and graphing our equations, we're going to start off with taking a look at our subintervals, which are going to be at a distance of 1/8. And since we're starting at a phase shift of negative 4/8, that means that our graph is going to extend towards the left-hand side. This would be negative 1/8, negative 2/8, negative 3/8, negative 4/8. Now we are looking at a sine equation. That is something to keep in mind as we start working and plugging in our points. In order to do that, we have to start off with our midline. In this case, our midline will be at 3. So 3 would be right here. We're going to go ahead and draw out our horizontal line representing our midline. We're going to draw out our maximum and our minimum. We're going to place our first dot on our phase shift. From here, since we are working with a positive equation, we would actually head up, back to the midline, minimum, and then back to the midline. This is going to show us at the same time where our asymptotes will end up being. In this case, our asymptotes will end up at -4/8, -2/8, and on that y-axis. You're going to go ahead, focus on the mountains and valleys. Notice in this case, our first mountain is right here on the left-hand side. This will extend upward. Our second to third asymptote will extend downward. And that would be our graph for slide 5. So let's take a look at slide 6. On slide 6, we have y is equal to 2 cosine of 4x minus 4 pi. We're going to continue working on this problem the exact same way we've done all the others. Our amplitude in this case would be 2. Our period is 2 pi over b, which is going to be 4, which simplifies to pi over 2. Our subinterval, which would be pi over 2 divided by 4, would actually give us pi over 8. Our phase shift is going to be -c. So notice we have a negative of a -4 pi, which will leave us with 4 pi over b, which is 4. That will give us an answer of pi. Now remember, our phase shift and our subinterval should have the same denominator. So our pi is now going to turn into 8 pi over 8 to match the denominator of the subinterval. Our midline in this case is going to be 0, and our range is going to go from -2 to +2. First thing we're going to do is draw our dotted line for our midline. Notice that's going to go straight across our x-axis since we're at 0. Also keep in mind, if our phase shift starts at 8 pi over 8, that means 8 pi over 8, 9 pi over 8, 10 pi over 8. We have 11 pi over 8 and 12 pi over 8. Now, keep in mind, every single time that we do this, we want to make sure to label out our x-axis. Now we are doing a distance of pi over 8 between every single one of our blocks. So keep in mind, our y-axis is going to begin at 0, and we're going to go over to 8 pi over 8 at our first little line. We are working with cosine, and since our midline is on the 0, we're going to go ahead and mark off our maximum, which is 2, our minimum, which is -2. Because we're working with a positive equation, we would start off at our maximum, which would be 2 for the 8 pi over 8. We would drop down for 9 pi over 8 to the midline. Our minimum for 10 pi over 8, back to the midline, and back up to the maximum. We're going to go ahead and connect the dots. Keep in mind, we have to stay within our minimum and maximum. So we want to go ahead and show how those ends curl back down for that graph. Once again, keep in mind, every time that it passes the midline, this is describing where an asymptote would be. In the case for the area between our asymptotes, notice this is going to open downward for our secant. And on the left-hand side, remember, since we are only seeing a part of the entire area, we would just go from the dot itself and go towards the asymptote. And the same thing will happen on the right side and flow towards the asymptote. Let's take a look at slide 7. Slide 7, we're working the problem the exact same way. First, translate it. Y is equal to 2 cosine x. Amplitude would be 2. Our period would be 2 pi over 1, which is 2 pi. Our subinterval would be 2 pi over 4, or pi over 2. Our phase shift is going to be negative c, which in this case is going to be 0 over b, which is 1. Our midline would be 0. And our range would go from negative 2 to positive 2. Now, once we have that part going, we're going to go ahead and draw our dotted line for our midline across the x-axis. We take a look at our subinterval, which is going to be at pi over 2. And we're going to go all the way up to 2 pi. So in this case, since we're starting off at our phase shift being 0, 0 would start over here. We're going pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. That is going to give us the opportunity to make sure that all of our lines that we have are going to be in the right place. Now we are working with a cosine graph. So we're going to go ahead, we're going to mark off our maximum and our minimum. Max would be 2, minimum would be negative 2. Since this is a positive equation and we're working with cosine, it's going to begin at the 2 marker. We'll drop down to the midline at pi over 2, the minimum at 2 pi over 2, back to the midline, back to the maximum. Once again, we're going to connect the dots. Make sure to have those curls coming back down for that graph. From there, we take a look at our midline. In this case, we're going to have vertical asymptotes at pi over 2 and 3 pi over 2. Take care of that area within the 2 asymptotes first. And as we work the left side, keep in mind, since we're starting off at the 0, 2 mark, we're going to go towards the asymptote. We're going ahead with the right side, going towards the asymptote. Now keep in mind, the main reason for this occurring in the first place is because, remember, we are taking a look at one period. The period that we are looking at actually kind of splits the left side and the far right side from you being able to see an entire area in between two asymptotes, and it's splitting it up in between the left side and the right side. So we are actually looking at three different regions: half of the first, the entirety of the middle, and half of the right-hand side. Let's take a look at slide 8. With slide 8, once again, we're going to go ahead and we are going to translate this into y is equal to negative cosine of pi over x over 4. Our amplitude in this case is going to be pi. Our amplitude in this case is going to be 1. Our period is going to be 2 pi over b, which in this case is going to be 1 pi over 4, which is the same thing as 8. Our subinterval is going to be 8 over 4, which is 2. Our phase shift is going to be negative c, which is 0 over our 1/4 or 1 pi over 4. Anything that has 0 being divided by some type of number will end up being 0. Our midline would be 0 since there is no d, and the range would occur from -1 to +1. We're going to go ahead and graph out the midline at 0, our maximum at 1, and minimum at -1. Now, in this case, since we do have subintervals of even numbers, we can go ahead and just mark them down as 2, 4, 6, and 8. We're also going to go ahead and start off our first point, which would be at our phase shift, which would be 0. Notice we're going to start off with our minimum because we are working with a negative equation. So start off here. In this case, we would go up to the midline. After the midline, we're going to go up to the maximum, back to the midline, and back to the minimum. In this case, remember to have those curls point back up. Take a look at our midlines. That's going to occur at 2 and at 6. Our middle area is going to show a full parabola going upwards. On the far left, notice we're going to get a half. It's going to go towards the asymptote. And on the right-hand side, we're going to get another half. And it's going to go towards the asymptote once again. Let's go ahead and take a look at slide 9. Now, in this case, keep in mind, we do have the 3 in the front, which is our D. As we go rewriting this problem, we're going to want to go ahead and put everything back in its place. Y is equal to 2 sine of x plus 3. Our amplitude in this problem would actually be 2. Period would be 2 pi over 1, which is 2 pi. Our subinterval would be 2 pi over 4, or pi over 2. Our phase shift would be 0 over 1, or 0 our midline would be 3, and our range would extend from 1 to 5. We're going to go ahead and graph out our midline, which is going to be at 3. So we're going to go ahead and label our actual x-axis as our 1. This line as our 3. This line as our 5. Keep in mind, anytime that you are changing the original graph, you have to go ahead and label it out as far as what's occurring. Keep in mind, our interval, our subinterval is pi over 2, and we are starting off at the 0 mark, which means this would be pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Now in this case, our equation is 2 sine x plus 3. Because it's positive, we're going to go ahead and start at the midline itself, which would be at 3 on the 0 mark right there. From there, since we have a positive equation, we're going to go to the maximum, back to the midline, back to the minimum, back to the midline. We're going to go ahead and connect the dots. From there, keep an eye out for any lines that hit our midline. In this case, it will happen on the y-axis. It will happen at 2 pi over 2 and 4 pi over 2. Since we have areas that are occurring between the asymptotes both times, we're going to see 2 full parabolas occurring on both sides of the asymptotes. Let's take a look at our last slide, slide 10. In this equation, we're going to go ahead. This would turn into y is equal to negative 2 cosine of 2x minus 1. Our amplitude is 2. Period is 2 pi over 2, which is the same as pi. Subinterval would be pi over 4. Our phase shift would be negative c, which in this case is 0 over b, which is 2, or just 0. Our midline is negative 1, and our range is going to go from negative 3 to a positive 1. Now in this case, as we're graphing, the graph does allow us to just go ahead and just draw out everything as is. So we can keep that x-axis as 0. Our first and maximum would be 1. Our negative 1 would be our midline, and our negative 3 would be our minimum. We're going to go ahead, draw out that midline. Now keep in mind, since we're working with cosine, we're going to either begin with the minimum or the maximum. In this case, it's going to be the minimum since we have a negative equation. Now, we're going to be looking at pi over 4 as our intervals. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. We're going to begin with the minimum, which is at negative 3. We're going to go up to the midline, up to the maximum, down to the midline, down to the minimum. In this case, we're going to connect our dots. We're going to take a look at the midline to give us an idea of where our asymptotes will be. And in this case, they are going to occur at pi over 4 and 3 pi over 4. Here we can see a mountain in between the two asymptotes. So our graph and our parabola is going to extend upward towards those. And on the far left side, we're going to end up with our dot and half of our parabola facing downward and going towards the asymptote. Same thing will occur on the right-hand side. It will extend down, and it would be half of a parabola. This covers all of 10.3. If you have any questions, please feel free to ask at any point.